Hey there, welcome to Math 2 Unit 6. This is our review worksheet for this worksheet, which you may have an upcoming test, or these same things could be worked into your semester final that's coming up in a few weeks as well. But here we go. Number one says solve the proportion. So to solve a proportion, we can cross multiply right away, or we can also choose to reduce right away. I know that 2 goes into here 4 times and 2 goes in here 7 times, so I have a little bit smaller number to work with, and that's probably the best way to approach this problem. I'll zoom a little bit more here for you, so that way you're not dealing with large complex numbers. So now when I cross multiply, I have 4 times 35, right? 4 times 35 here is going to equal to 7 and an x there, right? So what I'm going to do is another little shortcut trick. I can multiply that out. I certainly can, right? I could say that 4 times 35 is 140. So I'm going to do a little squiggle line here, right? I could say this is 140 equals 7x, okay? So with 140 equals 7x, I would divide by 7, and I have x equals 140 divided by 7, which is 20. But take a look real quick at another little shortcut I could use. If I notice my numbers ahead of time, I can recognize that 7 and 35 have something in common, right? 7 goes into 35 5 times. So if I was to divide both sides by 7 like this, right, that reduces down to a 1, and I have just an x there, and this becomes 1, and that becomes a 5. So now all I have to multiply technically is 4 times 5, which is 20, and that's my solution for number 1. Okay, so 2 ways of doing that. Again, a couple of approaches, depends on what you want to see. Okay, over here we have 3 over 5 equals x over x plus 10, right? Over 45. So let's do the same thing here. I'm going to multiply 3 and 45, and I'm going to go ahead and do this like this. I'm going to do 3 times 45, and I'm going to set that equal to 5 times x plus 10. Okay, so once again, what I can do, and probably what most of you want to do, is you're going to multiply this out. You're going to do 45 times 3, you'll do 135 on this side, and you'll distribute, and you'll do 5x plus 50. Okay, we'll subtract 50, subtract 50, so 135 minus 50 is 85 equals 5x. Divide both sides by 5, and you find out that x equals 17. Is there a shorter way to do it? There certainly is, right? Let's do a little squiggle line here. If I did 3 times 45 equals 5 times x plus 10, back to my starting point, if I was at this point here divide both sides by 5, I would eliminate the 5 there, right? And then 45 gets reduced down to 9 and 1. So now I have 27, 9 times 3 equals x plus 10, subtract 10, subtract 10, and 17 equals x. Right? So I just wanted to show you on both these problems a couple ways of approaching it, and so as you start to see your math facts a little more clearly, you can recognize some shortcut ways to kind of change things around so it becomes a little easier to solve. Right? So it all works. You end up with the 17 on both solutions, and that's how that works there. All right, number 3. It says given that KLM is similar to KQP, what makes these things work? Okay, we have K to Q. All right, so let's take a look at KQ. It says KQ, this long line, right, over KL, short line, is similar to something we don't know over KM. Now again, KM is here to here. So just color-wise, what I'm missing is I'm missing the length from here to here. And that length, when I look at that, is going to be K to P. So that becomes my solution, KP. All right. Number 4. Which proportion is accurate for the diagram shown? All right. We have C and K and D and M and H there. So let's take a look here. This one shows D, so the short side, to the whole long side is similar to the short side and the other part. That's not going to be a match, so we'd say no to that one. Here we have D to the long side, similar to K. Well, K doesn't match D, so we'd say no to that one there. That's not going to work. Okay. And we have D to H again, and we have C over c plus k. Well, c plus k is the sum of those two things together. This is c plus k, right? So what we're saying in this one here is that I have the short one to the sum, and then I have the short one to the sum. That would be a yes, that's going to match. Okay, looking at the next one, I have the dh, right? The dh and c over c minus k, that's not going to work, okay? So that'd be a no. Number 5. We have a boy, a 6-foot boy, has a shadow that's 4 feet. At the same time of day, a tree has a shadow that's 24 feet. What's the height of the tree? We're going to set this up as a proportion. We'll do the height of the boy over his shadow equals the height of the tree over its shadow, which is 24. I can reduce here, and 6 over 4 can reduce down to 3 over 2. Okay, and so we'll leave it like that for now. All right, and let's go ahead and cross multiply. So 3 times 24, 24 times 3, it's going to be 72. That's going to equal 2 times x, and I'll divide both sides by 2. 72 divided by 2 is going to be 36. So x equals 36 for number 5. All right, number 6. Similarity between the, so which similarity statement is true for the two triangles? So what we're looking at here is the order in which these things are listed. BCA, ABC, BAC, ABC, compared to the XYZ stuff. So let's get our labels here correct, okay? I see that the 25-degree angle measurement goes with the Z and the C, right? So I'm going to write this like this. I'll put a C here and a Z there because I know that they go together. All right. That means that this A measurement must be the 125, okay? And that's going to go with the Y. So let's put an A here and let's put a Y there because that's what corresponds there. Now the B is what's left, and the B one here, this B, is going to match the X, like so. So that's my order that I have to work with, but I could have this in several ways, but that's my basic order. So when I look at the ABC one, here's ABC, I need to find YXZ. So ABC, not that one. ABC, that's YZX, so that's not going to be working there. That doesn't work there. So far, I don't have those as answers. Okay. This one goes BCA. So that's moving this one over here to this side. So let's move it over there. Let's take a look at what we get now. So for BCA, I want to have XZY, and there it is, XZY. So that's going to be my solution, A. Number 7. A prime, B prime, C prime triangle is the image of ABC triangle under dilation with a scale factor of 2.5 centered at the origin. If AB, the original, is 8 units, what's the length of A prime, B prime? Okay, so what happens with a scale factor is we're multiplying the original value times that scale factor. So we're going to do the original, right, times the scale factor, and that's going to be our new value there. So 8 times 2.5 is going to be equal to 20, and that's going to be choice A. All right, let's turn to the back side. Number 8. Number 8, using the diagram below, let's see what we can find out. All right, so we have it says ABC matches GJL. So it's the same order here, ABC, GJL. Got it. Which makes this angle here 25, which makes this one here 100. Okay, so just some things in common. So angle B, which is here, we want to find out what angle B is going to be. It's going to match angle J. Since angle J was 100, this is also going to be 100 degrees. For the measurement of angle L, we're not provided with that one on either one of the triangles, right? So we have to do a little bit of math. Okay. So what we're going to do is we have 100 plus 25 as the values we have so far for 125. We need to see what's left out of 180. And so when we subtract this, we end up with 55 degrees is what remains for that angle measurement and that angle measurement. So angle L is 55 degrees. Scale factor of the smaller to the larger. All right, we have a couple numbers, 18 going to 22. Okay, so we could write this down as 18 over 22, and we can reduce. 2 goes in here 9 times, and 2 goes in here 11 times. So we could write that as 9/11ths, or we could write this as 9 dot dot 11. Just depends on how your teacher wants you to set that up. Okay. Looking at number 9. We have A, B, C, E, F this way around is matching W, P, right? So we're matching this way around matches this way around. Ah, interesting, huh? Okay, so find angle A. Well, angle A is the first one. It's going to match the first one over here, which is W. W is 85, so it makes A also 85 degrees. P is the second one here, right? That's our second one there. So it's going to match our second one here, which is B, which happens to be 120 degrees. So use the letters and just keep it the same order and you can find what you're looking for. Number 10. Determine if they're similar and then complete the similarity statement. All right, so TLZ. So TLZ, using L, the right angle, as our middle point there, is going to be similar to CLH potentially. Okay, that's what we have to determine. Is it going to be similar or is it not? If it is, then it's going to have a little scale factor here that's going to make sense for us. So we need to take a look at how are they getting from one to the other. Okay, so initially we have a length of 9. Okay, so on this side we have 6 and 9. So let's set that up as 6 over 9. All right, 6 over 9. And then we're going to say that that's going to be similar to 12 over 18. All right, is this true? Well, 6 over 9, what does that reduce down to? That reduces down to 2/3. And here, 6 goes in here 2 times, and 6 goes in here 3 times. And so because they're still going to be equal there, we're going to say, yeah, that's going to be similar. So it's going to work out okay. So let's make our triangle. We're going to go C, L, and H for the new triangle. And the reason that's going to be similar is because we have a side, angle, and side based upon our ratio stuff here that makes that work. Okay. Number 11. We have URE and we have this thing here. Well, notice that this is 42 degrees. What I have left is 88 and 42 makes 10, and I have 9, and then I have 12, 13, 130, which means the only degree measurement I have left is going to be 50 for this one right here. So right away what I notice is that I have a 88, 50, 42 triangle. Here I have a 42 and 70. So that's not matching, which means that this is not a similar triangle. It's not going to work. There's nothing similar about them. Okay, moving to 12. Here we have parallel lines. That's going to be okay there. Okay, with parallel lines, we know that the vertical angles are going to be congruent. We also know that the alternate interior angles will also be congruent. Okay, and that means this alternate interior angle also matches that one over there. So in this case here, the reason we know this is going to work is because our angle-angle theorem there, we're going to have the two angles are going to be together, and once you have two angles, the third one has to match. So let's get our order right here. We're going to go from the 3 to 2 to 1 in terms of my little marks here. So here we're going to go 3, 2, 1. So this becomes U, T, and S. The S one definitely has to be the one that's the same because it's using the same side there, and this one's on the straight line there. Number 13, we have LMP, okay, and we want to see if it's congruent to something else as well. So this is LMP. This becomes our right angle at the M part, but this is my kind of my longer leg here, right, going from L to M. So my long leg here is P to M, right? That's the long leg of this triangle. So we're going to do a P to M, and then my short leg kicks out to the N, so that's what matches there. Now this is going to be similar because I have an angle, and I have an angle, and once I have two angles, I know we're going to be good to go. All right, and number 14 here, we have some side lengths in this case. We don't have any angle measurements to know if they're the same, so we need to see if there's a relationship between the side lengths. So I can take this one here, the 6 and the 9. Let's do that since it opens up here, and let's do 6 over 9, and that can reduce down to 2/3, right? And now let's do the 8 and the 12 right here. So what does 8 and 12 reduce to? Well, 4 goes in there 2 times, and 4 goes in there 3 times, so that matches there, and we're good. I could double check with the 15 and 20, right? and see if that works as well. Anyways, you could play with that and see what you got. So either way, we know we're good to go, and because our sides match, this is going to be the same based upon side, side, side. And let's look at our order here. We went K, so the open one here, which is going to correspond to H, and then we went to G, so down the side that went like this, a little bit longer side, the medium sized side, so that's going to go to L, so this way to that way to L, and what's left is A. Alright, okay, now let's take a look at number 15 to 18. It says the following figures are similar, find the values of the variables. Okay, so we already know they're similar, so we can leave that, we know that's true. So the difference here between a 6 and an 8 in terms of a scale factor, it looks like we're multiplying by 3 to get from 6 to 18. Okay, so for the 5 to become a y, we're going to do 5 times 3, which is 15 here. And for the 4, we do 4 times 3 to find out the x value, which is going to be 12. Okay, sometimes it's pretty simple, just like that. For 16, we have a length here of x, a length here of 18, we have 36, 12, and something there, right? So let's first of all, let's set up and figure out what this is going to be. This entire length here is going to be 48, all right? In case I was kind of curious about that, that's my whole length there. This length right here, I can set it up as, I can do this. I could do the short side. I prefer to this. I prefer to the short side over the full length, okay? Well, we can do short length too, it's fine. We'll do it over 12. And we can set that equal to the short side here over the short side there. This I can reduce. I can say that, I can say 4 goes in here 9 times and 4 goes in here 3 times. I can say 3 goes in here 1 time and 3 goes in here 3 times. So I actually have 3 over 1, okay? And now I cross multiply, and we have 27 equals 1 times y, which is y. So my y value is 27. So we'll put that in right there. Now knowing that that's 27, I could then use my same kind of ratio that I have, which is 3 to 1, okay? And we can do 3 to 1. 3 is my longer side, or my first triangle. Is that right? Let's check this over. Let's adjust this here. 27. So let's do the x one. So the x one here, let's do the 27. How do you want to do this? Let's do this one here compared to the big one there. Okay? So we're going to do the 27 over 18 compared to our long one, which is 27 plus 9, which is 27 and 9 is 36 again. 36 over x. Okay? Now 9 goes in here 3 times and 9 goes in here 2 times. We cross multiply, so 2 times 36. 36 times 2 is going to be 72. Cross multiply, and we have 72 equals 3x. Divide both sides by 3. And so x equals 24. Alright, and that becomes my solution for x right there. Alright, there's my x and my y. Let's turn the page and see what we have on the next side. Alright, so again we have a couple things. We have the longer side, 15, over the short side, 5, equals our long side over the short side there. We reduce this to 3 and 1. We cross multiply, and we have 3x equals 27. Divide by 3, and x equals 9. Looking at number 18. Number 18. Okay, alright, so we have the, in this case here, we have the, I can do a side over the length, right? Side over the length, and make that equal to, in this case here, be careful, this I'm comparing a triangle, this side over the length, let's compare it to the whole thing over the length. This whole thing though is 15, and compared to the length, which is x. So now I can cross multiply, and when I do that one there, I have 7 times 15. Again, there's some shortcuts here, but I'm going to do it the long way. Equals 5x. Divide both sides by 5, and we have 21 equals x. Alright, number 19. Alright, so here we have x plus something is going to get me to 8, and here 3 plus something else gets me to 12. So I know in this case here that value is going to be 9. Why? Because 12 minus 3 is 9. Okay, so that tells me that now I can do 9 over the whole thing, which is 12, is similar to over here, x over the whole thing, which is 8. I can reduce, 3 goes in here 3 times, 3 goes in there 4 times, cross multiply, and 24 equals 4x, divide by 4, and x equals 6. All right, moving to 20. Okay, we have again the short side and a long side. It doesn't matter how you set this up. We can do 8 over 6, this one over that one, and make it equal to this one, x minus 4 over that one, 9. I can reduce, 2 goes in here 4 times, 2 goes in here 3 times, cross multiply, and we end up with 36 equals 3 times x minus 4. Okay, I can distribute or I can divide first. Let's divide first real quick. Let's divide both sides by 3. 36 divided by 3 is going to be 12. So 12 equals x minus 4. Add 4, and we have x equals 16. All right, moving down here, number 21. Okay, so we have a length with an opposite side, and a length and an opposite side. So those angles are the same. We're not sure about the other angles exactly, but let's assume that the one across from the angle that matches is going to be our similar point. So we'll say x over 9, this one over that one, is going to equal 8 over 12. Right? So those are lining up here, and these are lining up there. Reducing, 2 goes in here 4 goes in here 2 times, 4 goes in here 3 times, cross multiply, 18 equals 3x, divide by 3, and x equals 6. 22. All right, we have 14, 21, x plus 8, and x. Same idea, except now we just do 21 over 14. This one over that one equals this one, x plus 8, over this one, x. We can reduce this. 7 goes in here 3 times, and 7 goes in here 2 times. And now we cross multiply, so we have 3x equals 2 times x plus 8. We distribute, and we have 2x plus 16 equals 3x. I subtracted 2x from both sides, so that x equals 16, and I'm all done with that part, right? That's that part there, but notice I have to find out what df is going to be. That means I need to plug it back in here. It says that x plus 8 plus x is going to be my value of df. That's what df equals. df is the whole thing. It's this and that. So I got to plug 16 in here. 16 plus 8 plus 16 all together, that's going to make a grand total of 40 for the value of df. Okay, here we go. Going across an angle, I got a 20, I got an x, so let's do x over the other one, which is 12, equals 20 over the other one, which is 16. 4 goes in here 5 times, 4 goes in here 4 times, so reduce, cross multiply, and 4x is going to be equal to 60. We divide both sides by 4, and 60 divided by 4 means that x equals 15. Alright, so here we go. Let's take a look at this one. This one's a little bit trickier, but not too bad. We can see again the same idea. What's across is an x, what's across over here we don't know, but we do know. This value is going to be the whole length, 20, minus x, because that's my x value. That's what's left. So now we can set it up like we did before. X over 14 equals 20 minus x over 18. Alright, so we're good to go there. So we cross multiply, and we have 18x equals 14 times 20 minus x. Again, this is going to be a little bit bigger number than I want to deal with, but it's okay for now. I could reduce it, but we'll just leave it. Okay, so 14 times 20, I'm using the calculator, so I might as well, is 280 minus 14x equals 18x. So if I add 14x to both sides, I end up with 32x equals 280. Okay, and then 280 divided by 32 is going to be equal to 8.75 is what x is going to be equal to for that one. Not a whole number, but it does work out, and that's what you get. Okay, and the back side, coming to the end here. It says a student dilates the figure at the right using a center dilation of 0, 0, the origin, and a scale factor of 2. Which statement is true? So a scale factor of 2, that means it's going to be enlarging, right? Okay, it's going to get larger. So let's see what happens. Choices. Each angle of the dilated house will be similar but not congruent. Well, if it's just a dilation, angles are always the same. They don't change, so that's not true. Each line segment in the dilated house will be parallel to its corresponding line segment in the original house. This would be true because since we're dilating through the origin, everything just increases with the scale factor, right? It doesn't really change that much, so it's going to be true. They'll all be parallel. Some of the line segments of the dilated house may have different slopes than the corresponding line segments of the original house. Nope, the slopes are not going to change because the angles don't change. The distance between the vertices and line segments on the dilated house will be 4 times the distance between the vertices of the original. No, if it's a dilation of 2, the vertice distance is going to not be that. So we'd say no to that one. All right. Okay, cool. Now let's move down to 26. For the triangle, right, graph the figure representing a dilation triangle by a scale factor of 1.5 with a center at 0. So here's my 0 point there. I'm going to go ahead and just put that, I'll make it blue there for now. Okay, and let's graph this out there. So, a dilation of 1.5, it means it's going to be increasing by 1.5 more than what it was before. So, my original point here went over 1 and up 1, 2, 3. So I'm going to go over a half more because I already did 1, so I'm going to go over half. And since I went up 3, and so now I'm going to go up 1.5 to about here. That's that point here. On this point, I went down 2 over 2. So half of 2 is 1. So I'm going to go an additional 1 down and over 1 more. That's my half of 2. Over here, I went down 2 and over 1, 2, 3, 4. So again, half of 2 is 1, so I'll go down 1. And half of 4 is 2. 1, 2. So I'm going to go out to here. So my new line, our new triangle, is going to be located at these points. And so we play connect the dots here. And we get a shape that looks something like this. That one runs along the line there, no problem. And this one runs along the line, the diagonal here. All right, and that's where our points are going to be at. Should the two triangles be similar? We would say yes, because that's what happens when you do a dilation. Yes. Should the corresponding sides be parallel? Again, like our last problem, yes, they should be. Should they be congruent? Not with a scale factor of 1.5. Congruence means they're going to be the same. This is not going to be the same because we enlarged it. Should the angles be congruent? Always. The angles never change when you do a dilation. Okay, cool. And finally, number 27, make a 2-column proof to prove this is true. So our first thing will be our statement of what is given. Okay, and what we're given is that B line segment BS is parallel with WD. That is parallel to that, and that is given. So we know it to be true. The next thing we can look at is we know that angle BOS is congruent to angle W, or I can say DOW, right? And why is that? That's because vertical angles are congruent, right? So we know that this goes with that, okay? I can then say that angle D is similar to angle B because this is a parallel line, and this becomes an alternate interior angle. So alternate interior angles are congruent. I also then could say that angle W is congruent to angle S. Same idea, alternate interior angles are congruent. So 1, 2, 3, 4, 1, 2, 3, 3, sorry. And then finally, because I have 3 angles, I can say that triangle BSO is congruent to triangle DWO. And the reason is because I have angle, theorem. Okay, so there you go. That's it for your review. Hope that helps you out, and we'll see you next time.